this morning because we've already gone with the anatomy. But if I do that, it won't make any sense to those individuals that have not had lab. So I'm going to jump past that chapter and go into the lymphatics and immunity system. All right? So we're skipping. We'll come back to the cardiovascular system when we finish lymphatics. Okay, here is a blood capillary. The walls of the blood capillary are nothing but simple squamous epithelial tissue. And what do we know about the properties of this tissue? One layer of thin flat cells that allows a rapid exchange of molecules across its surface. All right? Here is a body tissue cell, and here is a lymphatic capillary. Like blood capillaries, the walls of the lymphatic capillaries are nothing but simple squamous epithelial tissue. But they differ. Notice that blood capillaries are open-ended tubes and lymphatic capillaries are closed-ended tubes. Now, in blood plasma, there are the albumins, there is water, and there are liquid-based nutrients. Now, at the arterial end of the blood capillary, the pressure behind the blood is sufficient enough to filter water and liquid-based nutrients out of plasma, but it's not sufficient enough to filter the albumins out. The albumins are too big. There's not enough pressure to move those big molecules. But we have to filter water and liquid-based nutrients out of blood because those are needed by body tissue cells. Now, at the same time, these body tissue cells are secreting liquid-based waste products. Now, the cells in the tissue cannot take up all of the water and nutrients that have been filtered out of blood. So those products, along with these liquid-based waste products, is going to accumulate in body tissue. Now, we already know that when you get a buildup of fluid in tissue, it's called edema. And edema can not only be painful if it's pushing on a pain neuron, but it could cause cell death if it's pushing on a blood capillary, restricting blood flow to downstream tissue. But we know that the albumins that remain behind in the plasma will help draw those products back into circulation at the venial end of this capillary. However, there's still going to remain an excess of these products in tissue that albumin cannot force back into circulation by correlated osmotic pressure. So those excess products will then enter into the lymphatic system. So the job of the lymphatic system is to pick up these excess products and return it back to circulation. Now, when these products enter the lymphatic system, they combined are now called lymph. Now, there is a possibility that when the lymphatic system is collecting this lymph, it may also pick up pathogens that are in tissue. And these pathogens can enter the lymphatic system and travel with lymph. Now, do you want the lymphatic system to deposit those pathogens into circulation? No, because then they can go anywhere in the body. They can result in a systemic infection. So these lymphatic capillaries are going to merge to form lymphatic veins. And these lymphatic veins are going to pass their lymph through lymph nodes. And then these lymph nodes are going to send the lymph to their collecting ducts. All right, so here is a lymphatic vein that is bringing lymph into the lymph node. Here is the lymph node. A little bit bigger. So here's the node. So here are afferent vessels that are bringing lymph into the node. Here are efferent vessels that is carrying lymph out of the node. Now this node has a lot of walls or chambers in it. And housed in these chambers are a special class of lymphocytes called B and T cells. Now, if there is a pathogen in lymph, it's the job of the B and T cells in the lymph node to detect that pathogen and destroy it before the lymph exits the node. Now there's a special region on the lymph node right here that's called the hilum. And the hilum is where blood vessels enter and exit the node. Now, if these B and T cells in the node detect the presence of pathogens, they will send a signal to the body, and the body will send in more B and T cells through circulation to enter the node. And this is going to cause the node to swell. More stuff is coming into it. It's going to get bigger. So it's not uncommon for you to go to your doctor and he'll feel around on your neck, he'll feel around under your arm, and he's feeling for the size of your lymph nodes. Because if you have swollen nodes, it means there's something going wrong. You probably have a systemic infection. So hopefully by the time that the lymph passes through this node, it is totally free of pathogens. And then it's going to enter one of two collecting ducts. The largest of the duct is the thoracic duct. It is going to collect lymph from the legs, the torso, left side of thorax, left side of head and neck, and left arm, and it's going to send that lymph into the left subclavian vein. So the legs, the torso, the left side of the thorax, the left side of the head and neck, and the left arm. And then it's going to dump that lymph into circulation at the left subclavian vein. The smaller of the two collecting ducts is the right lymphatic duct. And it collects lymph from the left side, the right side of thorax, right side of head and neck, and right arm, and it's going to send that lymph into the right subclavian vein. We haven't learned about this vein yet. We'll learn about it next week in lab. But below clavian for clavicle. So it's a vein that's passing right underneath your clavicle. Yeah, because it's doing the legs and the torso and the left upper side of the body. The right lymphatic duct is only doing the right upper half of the body. So the thoracic duct is considerably bigger.
What did you say about the lymph? It picks up products and brings it back to what?
Circulation.
Okay.
See, if there's any excess water and nutrients in tissue that's not pulled back into circulation by the albumins, it's going to be picked up by lymph and returned back to circulation so circulation can redistribute it to the body. All right? The body wastes nothing. All right? It only gets rid of what it has to get rid of. Okay, that's the lymphatic system. Any questions over that? Can't get any simpler. Now the bitch of this chapter is the immune system.